Okay, so I'm going to make this video for chapter 17, learning activity number 23. It's subnet masks and subnetting. Um, Basically, we learned about this stuff back in, must have been about 5 or 6 chapters ago. But this activity is a little bit different because before we were given an IP address that had a IP address of basically starting with zero. And what really wasn't an IP address, that was just our numbers given for the first three octets. And then we started with zero and then we subnetted. So on this activity, we're using this IP address. And basically, what's going to happen is you got to imagine the reason why they give us an IP address is just imagine for a second you have a computer lab with like 5 computers. And so you actually find one with the IP address 175.30.150.221. And you're saying to yourself, okay, so something's wrong with this computer, but it must be something in the network. And so you want to go find the switch that is assigned to, that way you know basically where to start troubleshooting. So what you do is you start looking at your documentation of what your network looks like, and that's where you can find out what subnet it's on. That way you can go target the one piece of equipment or the wires that you need to look at. So in this activity, what they do is it says right here, it says finish the first 3 columns, um, complete the first 3 columns. So we know exactly how to do this piece. This slash notation, that's pretty easy. Binary subnet mask is fairly simple, and dotted decimal subnet mask is easy. And even the increment is pretty easy to come by. It's the network, the broadcast, and the host that's going to be a little bit hard. Now, the thing that we have to consider is this is not only a Class C subnetting. This is also a Class B demonstration. So we didn't go over Class B. So that means that we're going to do everything in this column. We're going to do everything in this column. We're going to do everything in this column and in this one. But when we get to network, broadcast, and host, we're only going to do rows 1, 2, 3, and 4. So what's going to happen is this section right here, and I wish I could highlight it in the video, but this starting right here in this one, going all the way to this corner right here, we're not going to do any of this. So we're going to miss a big, maybe a fourth, maybe a little less than that on the documentation. But it's because we don't know exactly how to do Class B subnetting. So let's go ahead and take a look at, I guess what we need to do first of all is download the document. So I'm going to go ahead and download it. It's a Word document. I might have to pause the video a couple times because I know how my computer runs. So I'm going to go ahead and put it on my desktop and let it download. Then I'm going to wait until it's finished and open it up. Let me go ahead and open another tab while that's working. And I'm going to open up Whiteboard. Now, we didn't use Whiteboard much in the classroom, but because I had a whiteboard. So I'm going to go ahead and use a free online whiteboard. And hopefully my actual writing won't look too bad. Maybe I'll be able to decipher what I'm working on. So what I'm going to do is I'm going to go ahead and look at the document. So I'm going to kind of be flipping back and forth. Still loading. I'm going to go ahead and pause it just for a second. Okay, so now it's finished getting ready to go. I'm going to enable editing. And I'm going to look real quick at the document. Let me try to change the view a little bit so that way we can get as much of the document in the picture as we can. No, I don't want to make it too small. Okay, going to go ahead and maximize it. And I'm going to start with explaining the slash notation real quick so that way you can understand, try to remember where this comes from. The slash notation, remember there's slash 8. Sorry, this is supposed to be a slash like this. And there's slash 16. And then there's a slash 24. And so if you can't remember where those come from, this is just the way they notate when you're dealing with your class A, class B, and class C. This is class A. And what that means is basically you have 8 octets. And I'll show this on the screen in just a second. So this is class B and this is class C. So when I'm talking about the first 8 octets, I'm talking about the first 3 numbers that you have right here. So you got X, and then you got dot, and then you have the rest of your other, pieces that are in here in your second octet. And sorry, I wish I had a pen and a pad. That would actually work better. But you have the next 2 octets, and then you have your final 1, 2, and 3 octets. So what happens is when you do a slash notation 8, that means that I'm using the first 3 octets, or the first octet. So that means this 8 goes with this. So you got to remember in binary, it's actually not 3 digits, it's actually 8 bits. So that's where the 8 comes from. And if I want to do 16, then basically on my IP address, I'm gonna have the first 6 numbers. Of course, the dot keeps them separated. But what that means is I have 16 bits I'm working with. And the last is true for the C class, is that I fill in the remaining IP component, and I'm left with 24 bits. And what I'm referring to is if I was going to do this in actual binary, I would have 1, 2, 3, 4, 5, 6, 7, 8, and then a dot, and this would be equivalent to this. So that's where I get the 8. And then say I want to do the remaining, it'd be 8 more right here, which is 16, and then 8 more on the last one, which is 24. So if you just keep that in mind, we should be able to do slash notation pretty easy. See if I can erase this and how you erase it. Hold on, let me pause for a second. Okay, so then I'm going to look at binary, which I kind of explained when I was doing slash notation. Binary is basically a way of showing how many bits we're borrowing, or how many are actually being used in the subnet mask. And then, of course, the dot decimal subnet mask is the equivalent in decimal to whatever your binary subnet mask is. So these two numbers are exactly the same. It's just one's in binary and one's in decimal. That's the only difference. And the increment, if you knew anything about Class C subnetting, the increment is that point that's right, is the last borrowed bit. And I'll try to demonstrate that a little bit better in just a few seconds. So I'm going to look at number 1 to kind of start us off. So we got 27. We don't know what the binary subnet mask is, or the dot decimal subnet mask, because remember, these two are going to be the same. And then the increment is going to come off of what this notation is indicating. So I'm going to do a let's see if I can get this right. Ooh, that's not good. Hold on, maybe a pencil. Okay, there you go. That's better. Okay, well, I'm just going to go ahead and do the best I can with this. This is the first time I've done it. So the number is 27. What that ultimately means is that I'm taking um, the subnet mask, uh, which is 1, 2, 3, 4, 5, 6, 7, 8, and then putting dot 1, 2, 7, 8, which is another octet. 1, 2, 3, 4, 5, 6, 7, 8, which is the next octet. Now this is, remember, this is slash 24, but we got to make it to slash 27, which means that we're going to need three more. We already have 24, so that's 25, 26, and 27. Now, that's our binary number. However, we got to fill in the remainder zeros. Well, it's only five more zeros. So I'm going to put a zero, a zero, a zero, a zero, and one more zero. So there's the remaining five zeros. So this is a slash 27. So what I've just kind of run down again, that means the first octet is full, second octet is full, third octet is full, which makes slash 24. But then I got 25, 26, and 27. So this is the number that you would write in here. So going back to this document, I would type in, basically an easy way to do this activity is just kind of control C right here and then control V. But remember, this number at the end changes, so it's supposed to be 50. So that means I take one of these ones away and put another zero in there. So I have three ones right here, one, two, three, and five zeros. So this is the number that goes with that. Now, the other part is you're saying, well, what about the subnet, the dotted decimal subnet mask? Well, we all know that the subnet mask is going to be 255.255.255 dot something, but we're not sure what the something is yet, because what we have to do is we have to come over here and look at what bits are being borrowed, and so that's where we come back to the this. Sorry, that's where we come back to the next piece, which is we have these three right here. Now, one of the things you have to keep in mind is always keep this chart in mind that we have when we convert the binary and the decimal. Remember, it always starts with one. I'm wrong. It starts with one, zero. Then it has a one, and then it goes to two. Then it goes to four. Remember, you're gonna go to it's basically 8 bits in an octet. So 4, 8. Sorry about the 8. 16, 32, 32. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, and then okay. Well, I'm actually wrong. How did I get 9? Oh, you know what it was? There's no well, no, there's a one. So I'm trying to think. So two to the, remember this first position is 2 to the 0 power. So what is 2 to the 0 power? I can check it real quick. What is 2 to the 0 power? 2 to the 0 power is 1. So okay, so yeah, where I made a mistake is that there's no zero at the beginning. So let me go ahead and erase that. I don't want to confuse you, but so basically, when you're setting up this chart, remember you're starting with 1, then it goes to 2, then to 4, then to 8, 16, 32, 64, and 28. Now that we got 8 bits, I look up here and say, okay, Well, the numbers I'm using are the first three, and so I take I take 128 and I add it to 64 and I add it to 32, and then that's going to give me the decimal equivalent to this binary number. So 128 and 32 is 160. So 160 plus 64, 160. Remember, I just added the first number to the last number. 160 plus 64 is, it's going to be at the 4 at the end. And you got a 12, and it's 2. So it's 224. Sorry, my handwriting is horrible. I don't know, especially in this board. So basically, what happens is on this number right here, the decimal is 224. And that sets up one last thing, the increment. So we know that the increment is where the octet. Sorry, I'm trying to back to the whiteboard. Um, that we borrowed. So basically, in this scenario, we say 1, 2, 3 is the bits that we borrowed. So you have 1, 2, 3, and right here is where we stop. This is where we tell the computer, hey, we're going to keep these free for the host, and we're going to use this for the. This is the part that indicates the network area that we're working with. So we know that we're stopping on 32. So this is your increment, and that happens in all cases. So if we only borrow two of them, 1, 2, then increment 64. If we borrow four of them, 1, 2, 3, 4, our increment is 16. So wherever this number indicates, that last bit is our increment. So right here, we're going to put increment is 32. So type in 32. And that fills in for most of it. Now, I know this is kind of long and drawn out. It actually goes by a little bit quicker once we start looking at the pattern. So on this next one, we see that we borrowed 4. 1, 2, 3, 4. And hold on one second, check something real quick. Okay, so we borrowed 4. So what does that mean? Well, that means that we're going to add 4 to 24. Because we borrowed 4 right here, it's one more than the one before it. So if that's true, then we got to do a slash 28. So we added 4 to 24. That's 28. And with that said, we can actually fill in this next piece by doing 255.255.255 dot, and it's not 224. Remember, it's now one more than the number we worked with before. And the number we worked with before was stopped right here. Now we're actually dealing with this number right here. So let me erase it so there's no confusion on what's going on. Because what it is now is we borrowed 24. We borrowed 4, sorry. And then we've added that to 24. And I know there's probably an easier way to do this. There's always an easier way. I just haven't figured it out yet. So, and I'm going to go ahead and in fact erase this. You don't need to know any of this stuff right here. Okay. So now we're dealing with 32 and put the 16 that I erased. And so now we borrowed 4. Remember, and by the number we're working with, we borrowed 4. So I'm going to go back to this whiteboard, and I'm going to stop right here. So there's my increment, and I'm also dealing with the 16 more than I had in the last one. Well, the last one I had was 224. That was my decimal. So now I'm adding 16. And if I'm confusing you and you're saying, well, wait a minute, where did he get 224? Remember in the last, on example number one, I had 128 plus 64 plus 32, which is 224. Now I'm adding 16 more. So it's 10, 1, 40. Your number is 240 is your decimal equivalent. So I'm going to go back to here and 240. And that's basically the pattern is 224, 240. It's one more than what we borrowed from the last one. And if that's true, if you remember what I said about the increment, um, it stops on 16. So that's your increment that you're going to put in there. So I type in 16. Now that makes it pretty easy. What happens is you'll start noticing the pattern. If this is 252, and I'm working from 240. Well, if I add one more, that's 248. So remember, that's 248. That's not what the number we're looking for, but that is 248. And you can keep that up there because you might need it in a few minutes. This is where I borrowed 6 bits. Remember, this is 5, this is 6. And if this is 248, and I add, that was 8, and I'm going to add 4 more. Sorry about the 4. That'll be 252. And this is where I borrowed 1, 2, 3, 4, 5, 6 bits. This is where I borrowed 1, 2, 3, 4, 5 bits. So I just kind of put that out there. So this is 6 bits that I borrowed. Keep that in mind because when I go back to the sheet, you're going to be like, okay, there's 6 bits he borrowed. What was the increment? When we look back here, I stopped on 4. This is where I would have stopped. So my increment is 4. I put that there, and I said I had to borrow. I didn't borrow. I borrowed how many? Let's see. Sorry, I forgot myself. Hold on. Borrowed 1, 2, 3, 4, 5, 6. So I borrowed 6. Go back here, and I'm going to borrow 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2. Last two numbers being 0. And the slash notation, since we borrowed 6, we have to add that to 24, which means it's a slash 30. So, we're not gonna have too many problems here. In a few minutes, you'll see how it starts to show a pattern. Network and broadcast and the host are the ones we're gonna have trouble with, and that's gonna be a little bit longer in the video. So since this is 28 and this is 30, you can kind of reason if I borrowed 4 here and I borrowed 6 here, that means this one has to be 5 that I borrowed. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I said I borrowed 5, so it's 1, 2, 3, 4, 5. 6, 7, 8 bits. And how I got that is since I borrowed 5, I can tell his notation is 29. I borrowed 5. I needed 5 more to make 29 from 24. And so if you remember from the thing too that I haven't erased, on the blackboard we said this is 5. So it's 248. So 248 is 255.255.255.248. And then also in the increment, since we remember from the chart we're working with, on here we said we stopped at the 8. That's what we had to add to get to that. So that's the increment. So the rest is pretty, you're going to start noticing the pattern. The pattern is basically you got 252. So now this is where they start dealing with the B subnetting. And I'm not going to lie to you on this increment. This might be different too. So let's go ahead and leave that off for now because I do know all of this is correct, but I'm not 100% sure about the rest of this. Let's go ahead and see what notation this is. Now remember, On this one, C class, we're borrowing 20, or we have 24. Now we're on a B class, which we didn't study, but we can kind of put together by reasoning it. A B class is slash 16. Well, if on 52 we borrowed 1, 2, 3, 4, 5, 6, and I said that the notation is 16, so I'm going to do a slash 16 plus 6 is 22. So just keep that in mind that I'm borrowing from this piece, not the last octet. And you can still you can still copy and paste if you want, or you can just put in some ones, 1, 2, 3, 4, 5, 6, 7, 8. Wait, did I do 8? No, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now we're dealing with the next part, which is the third octet, and it's 52. And for 52, which that's the same here. It says here I had to borrow 1, 2, 3, 4, 5, 6. So I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, which completes the octet, and everything else is zeros. And that's how you come up with the binary equivalent to this. Now, remember, I'm not going to mention the increment right now because I'm not 100% sure on that one. Let's see if we can finish up this real quick. We're looking at I'm borrowing 4 right here. Well, if you're borrowing 4 and you're adding that to 16, remember we're dealing with class B now. If I'm borrowing 4 and adding it to the 16, I get a slash 20. And if that's true, and I'm borrowing 4, I look up here. Well, when I borrow 4, it's a 240. So the same pattern holds true because you're dealing with the same numbers, just different octets. So 240.0. And there's my notation. 19. Well, we start with 16. We're only going to borrow 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, gotta take that back because remember now we're in the right this octet. So I'm borrowing 3. So 1, 2, 3. 1, 2, 3, 4, 5. No, that's it. 5 because it's a total of 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. And since it's 19 and we borrowed 3, well, all we had to do is look up here. When we borrowed 3 originally, it was 224. So the same thing holds true. It's just now in a different octet again. 224.0. There you go. And that's the binary. That's a decimal equivalent to this binary number. Now, I can see 192. Well, if I look up here, I didn't have a 192. Right? So I can't use that. But what I can do is go back to my whiteboard. And I'm going to erase this calculations right here. So I'm just going to go real fast, see if I can get rid of some of this. I know there's a button that clears everything out, but I haven't figured it out, and I'm not going to stop the video for it. Almost there. So we said that the number we're dealing with is 192, I think is what it said. Yep, 192. So I need to get to 192. I'm going to kind of put that right here. This is a reminder, so I have to go back and forth. So what numbers, and remember, it's all in order, so we know we're going to need a 128. Oh, goodness, sorry. Okay. So I know I need a 128. And if I add 128 and 64, this is with me borrowing 2. Is that 192? Well, this is 12, and one more is 192. Okay, so we did find it. So we're borrowing 2 bits, the first 2. So we're borrowing these right here. So that's 2 of them. Let's go back to our document. So we're only borrowing 2. So remember, you're starting with 16. We're borrowing 2, so you got to add 2. So it gives you an 18. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, because I'm only borrowing 2, and then I got to fill in the rest of them with six more zeros. 1, 2, 3, 4, 5, 6. And then the remainder is all 8s. There you go. So the last two of them are not that hard, but we do know for a fact that this is 23. Now you got to think the number for Class C slash notation is 24, which means that we have used all of these to borrow. So she's done enough ones, yeah. So dot 1, 2, 3, 4, 5, 6, 7, 8. And now that means that I've added 7 more to my 16 to get 23. Remember, we started with 16 and we have to add 7. So 1, 2, 3, 4, 5, 6, 7. And we need one more zero for your last octet. And then we fill in the rest of the zeros. There's your equivalent. Now that's super close to being almost a Class C, but it's not because we still have one more bit. And if that is true, and that last one is a 1, then all you have to do is just kind of put the math to it. And it's not 254, it's 255, it's 254.0. Because we almost use everything except for that last one, the last number 1. What I'm referring to is this one right here. You see the last piece is a 1. So 255 is always the biggest. 255 is always the biggest number we can have. So we didn't use all of 255. We were minus 1, which is 250. Oh my goodness, sorry, 254. 254. So that's how we come up with that number right there to get to 254.1. And the last one should be pretty easy. It's 1, 2, 3, 4, 5. We borrowed 5. So we add 5 to 16, which is 21. The other thing is now we're still at 255. We're always doing the 255s. Now this is where it changes. How many we borrow? 5. Is there any up here we borrowed as 5? Right here. 1, 2, 3, 4, 5, which is 248. And so I use 248 there, and I just put that last zero. So that fills in pretty much the whole thing. Now the only part is that we got the network and the broadcast and the host. At this point in the video, I'm not going to lie to you, just turn in that, and then I'll remember, and I'll go ahead and grade it, because it's going to take about another 30 minutes to explain this piece. And then I just really want you to get this one document turned in for this class, and then I'll recreate the video all over again.